So today in the class we will learn about inverse trigonometric functions. First we will see a few points in the synopsis. As already it is evident that there are 6 inverse trigonometric functions. They are sine inverse x, cos inverse x, tan inverse x, secant inverse x, cosecant inverse x, and cot inverse x. Each function has their respective domain and range. For sine inverse x, the domain, that is x, can be taken from negative 1 to 1. For cos inverse x also from negative 1 to 1. But for tan inverse x, we can take any number from negative infinity to infinity. And for cot inverse x also, we can take x as any number from negative infinity to infinity. Whereas for secant inverse x, we can take less than or equal to negative 1 and greater than or equal to 1. Similarly, for cosecant inverse x also, x can be taken less than or equal to negative 1 and greater than or equal to 1. Coming to the values of y, or the range. For sine inverse x, y is from negative pi over 2 to pi over 2. Whereas for tan inverse x, y will be just between negative pi over 2 and pi over 2. For cos inverse x, y will be from 0 to pi, whereas for cot inverse x, y will be between 0 and pi. For secant inverse x and cosecant inverse x, for secant inverse x, y will be from 0 to pi, but y will not be equal to pi over 2. Whereas for cosecant inverse x, y will be from negative pi over 2 to pi over 2, but y will not be equal to 0. Now there are some formulas to be used. That is, sine inverse of sine theta will be theta. Similarly, cos inverse of cos theta is theta. Tan inverse of tan theta is theta. But that is applicable only in their particular ranges. Only when ranges are to be followed. In the ranges. Similarly, the other ones also. And in the same way, sine of sine inverse theta is theta. Cos of cos inverse theta is theta. And tan of tan inverse theta is theta, but in their particular domains. The inverse domains. Theta in the domains. Here in ranges. Theta should be in ranges. There are other shortcut formulas, but some shortcut formulas I prefer. It is better not to use them. We can use the long method only. Some formulas more are sine inverse x plus cos inverse x is pi over 2. Similarly, tan inverse x plus cot inverse x is pi by 2. And secant inverse x plus cosecant inverse x is also pi by 2. For these formulas, you can remember these formulas, which are helpful. Similarly, for tan inverse x plus tan inverse y, formula is tan inverse x plus y by 1 minus xy. But here the condition is xy should be less than 1. For the same thing, we have another formula, tan inverse x plus y by 1 minus xy plus pi. This is applicable when xy is greater than 1. The next formula is tan inverse x minus tan inverse y is tan inverse x minus y by 1 plus xy. Some more formulas, sine inverse of minus x is minus sine inverse x. Cos inverse of minus x is pi minus cos inverse x. Tan inverse of minus x is minus tan inverse x. Cot inverse of minus x is pi minus cot inverse x. There are some more formulas. If you want to remember, you can remember. Otherwise, we can go to long methods. That is, sine inverse x is cos inverse root of 1 minus x square. And for the same thing, there is another formula, tan inverse x by root of 1 minus x square. Or there is one more formula, cot inverse root of 1 minus x square by x. Or you can write it as another formula, secant inverse 1 by root of 1 minus x square or cosecant inverse 1 by x. Like this, you have total 5 formulas for sine inverse x. Not only for sine inverse x, for cos inverse x also 5 formulas are there. One is sine inverse root of 1 minus x square. The second one is tan inverse root of 1 minus x square by x. The next is cot inverse x by root of 1 minus x square. The next one is cosecant inverse 1 by root of 1 minus x square, or the last one is secant inverse 1 by x. Similarly, for tan inverse x also, first formula is sine inverse x by root of 1 plus x square. The second one is cos inverse 1 by root of 1 plus x square. The third formula is cot inverse 1 by x. The next one is secant inverse root of 1 plus x square. And the last one is cosecant inverse root of 1 plus x square by x. Similarly, we have another set of formulas like 2 cos inverse x is cos inverse 2x square minus 1. 2 tan inverse x is tan inverse 2x by 1 minus x square. There is another formula for this, that is sine inverse 2x by 1 plus x square. One more formula, cos inverse 1 minus x square by 1 plus x square. Similarly, 3 sine inverse x formula is sine inverse 3x minus 4x cube. 3 cos inverse x formula is cos inverse 4x cube minus 3x. 3 tan inverse x formula is tan inverse 3x minus x cube by 1 minus 3x square. Similarly, sine inverse x plus sine inverse y is plus or minus, we will take both the formulas, is sine inverse x root 1 minus y square plus or minus y root 1 minus x square. Similarly, cos inverse x plus or minus cos inverse y, you can make a formula. But for sine inverse There is one more formula also. That is pi minus sine inverse x root 1 minus y square plus or minus y root 1 minus x square. For this formula, the condition is x and y should be positive, greater than or equal to 0, and x square plus y square should be less than or equal to 1. If this condition is satisfied, then we can use the second formula. The next is sine inverse of cos theta is sine inverse sine of pi by 2 minus theta, or which will be equal to just pi by 2 minus theta. Similarly, cos inverse of sine theta can be written as pi by 2 minus theta. Like this, you have another set of formulas. So we can do some questions based on this. For example, the first one. If 2 tan inverse of cos theta is equal to tan inverse of 2 cosecant theta, then you have to find what is theta. So we can do it in a long way. And that is this left hand side. You can write this as according to the formula 2 tan inverse x can be written as tan inverse 2x by 1 minus x square. This is what you can write. Or you can write this as tan inverse 2 cos theta by 1 minus cos square theta as it is. So I will not change this actually, but I will change the other one. On LHS, I will change this. For that, I will write tan inverse 2 by sine theta. On the right hand side, I can write 2 by sine theta, isn't it? So I will write 2 by sine theta. Because these two are equal, I'll remove tan on both the sides. So 2 cos theta, now I will write denominator sine square theta equal to 2 by sine theta. So I can cancel 2 on both the sides. I can cancel 1 sine theta. So cot theta is 1. That means theta is pi by 4. And for this equation, the general solution, I can write tan theta equal to 1 and the general solution as n pi plus or minus pi by 4. Because plus pi by 4 is generally taken, so we will take just plus pi by 4. And this is how comes the answer for the first question. Coming to the second question. You have to find the value of 3 tan inverse 1 by 2 plus 2 tan inverse 1 by 5 plus sine inverse 142 by 65 root 5. So what I will do here is I will write tan inverse 1 by 2 and 2 tan inverse 1 by 2. Then 2 tan inverse 1 by 5 and sine inverse 142 by 65 root 5. From these two, I can pull out 2 common. So left is tan inverse 1 by 2 plus tan inverse 1 by 5 plus sine inverse 142 by 65 root 5. Now I can use tan inverse x plus tan inverse y formula, which I have written in Synopsis. That is 2 outside tan inverse x plus y by 1 minus xy plus sine inverse 142 by 65 root 5. Or I can write this as tan inverse half plus 2 tan inverse 5 plus 2 7 10 minus 1 9 plus sine inverse 142 by 65 root 5. Now, for this sine inverse, I will take a right angle triangle and I will write opposite as 142 and hypotenuse as 65 root 5. And then I can get the adjacent by using Pythagoras theorem. I will get 31. So I can write tan inverse half plus tan inverse 7 by 9 plus another tan inverse 7 by 9. Sine inverse, I can change it as tan inverse 142 by 31. So that I can add up these two and these two separately using tan inverse x plus tan inverse y, tan inverse x plus tan inverse y. Or instead of doing like this, we can do it in another way. Because we have tan inverse 1 by 2 and tan inverse 142 by 31, we can add up these two. And then for 2 tan inverse 7 by 9, I can use 2 tan inverse x formula. Here tan inverse x plus tan inverse y. So I will have tan inverse x plus y by 1 minus xy. That is 71 by 31. And here 2 tan inverse x. Tan inverse 2x by 1 minus x square. This is what I have. So I can simplify this and I can write tan inverse 315 by 80. And here I can simplify and write tan inverse 126 by 32. But here I will be having minus sign. So when you cancel, may simplify it, you'll have tan inverse 63 by 16 negative and tan inverse 63 by 16 positive. Together it becomes 0. Let's go to the third question. Third question is finding sine inverse cot of sine inverse root of 2 minus root 3 by 4 plus cos inverse root 12 by 4 plus sine inverse root 2. The value of this you have to find. So, first of all, sine inverse root 2. We will simplify the easy ones first. Sine inverse root 2. What will it be? It will be nothing but cos inverse root of, this is x suppose, 1 minus x square, which is not useful. This formula cannot be used because under the square root, you're getting a negative term. So, in order to write sine inverse root 2, the only alternate left is it is cos inverse 1 by root. Similarly, cos inverse root 12 by 4, I can write cos inverse. After simplifying, I can write it as root 3 by 2. And lastly, sine inverse root of 2 minus root 3 by 4. I can write as sine inverse root 3 minus 1 by 2 root. Just on simplifying. So this will be angle 15 degrees. This will be the angle 30 degrees. And this will be the angle 45 degrees, which you are adding. So total you will get 90 degrees. That means you have 90 degrees, and inside the parenthesis, inside the brackets, you have 90 degrees. But outside you have cot, and still outside you have sine inverse. So cot inverse of 90, it is 0. Sine inverse of 0 is 0. Next, coming to fourth question. T1 is sine inverse x power sine inverse x. T2 is sine inverse x power cos inverse x. And T3 is cos inverse x power sine inverse x. Lastly, T4 is cos inverse x power cos inverse x. You have to arrange them in decreasing order. Decreasing order. So one by one, we will start observing. How? In the question, one information is given. X belongs to 1 by root 2, comma sine. This interval. With the help of this, we can solve this. Write it in decreasing order. So x will be in between 1 by root 2 and sine 1. Or sine inverse x will be in between 1 and 1 by root 2. Or I can interchange it. I will interchange it. Like I will write sine inverse x will be in between. Here you can take sine inverse of sine 1, and here you can take sine inverse of 1 by root 2. That means sine inverse x will be between 1 and cos inverse x. So with this we can say of all, greatest is T2. The next greatest you can see, but the least, T2 will be greatest, but the least will be T3. And we also know that T1 is greater than T4. So this will be the decreasing order. Coming to fifth question. You have to find, or you have to solve, sine of 2 times cos inverse of cot of 2 tan inverse x equal to 0. This equation you have to solve. So first 2 tan inverse x I will write tan inverse 2x by 1 minus x square. This is what I can write, which will be same as cot inverse of 1 minus x square by 2x. All these are formulas. But outside you have this cot. So this will become just 1 minus x square by 2x. So now outside you have cos inverse. And outside cos inverse means how can you write? Because you have sine of 2 cos inverse. Isn't it? So suppose if you take a right angle triangle, adjacent is 1 minus x square and opposite is 2x. So using Pythagoras theorem, you can say what will be the third side. How? You can take square root of 4x square minus 1 minus x square whole square. That is 4x square minus 1 plus 2x square minus x power 4. And that will be minus 1 plus 6x square minus x power 4. It's becoming difficult to find the third side. So instead of going for this, we can't use this formula, we can't use Pythagoras rule. So you can use the formula. Which formula you will use? You will use sine of 2 cos inverse only, but this you will think it as theta. That means you have sine 2 theta. So formula is 2 sine theta cos theta. But because we have taken cos inverse 1 minus x square by 2x as theta, cos theta will be 1 minus x square by 2x. And sine theta will be square root of 1 minus x square whole square by 4x square. This is what you have for sine theta. Or sine theta can be simplified as 4x square minus 1 plus 2x square minus x power 4 by 4x square, as I have written earlier. So now I will write 2. In place of sine theta, I will write square root of 6x square minus 1 minus x power 4 by 4x square. And in terms of cos theta, I will write 1 minus x square by 2x. So 2 and 2 cancels. Now how to simplify this? I can write this as square root of, instead of multiplying, I will keep like this, 4x square minus 1 minus x square whole square over 2x square and the other side, whatever I have, I will write it as 1 minus x square. So this entire thing will be equal to 0 as per the equation given. That means square root of 4x square minus 1 minus x square whole square into 1 minus x square must be equal to 0. Or 4x square minus 1 minus x square whole square must be 0, or 1 minus x square must be 0. Here, x square will be equal to 1, x will be equal to plus or minus 1. But we have to solve this equation also. This will be 2x a plus b times a minus b. A plus b times a minus b equal to 0. So we have x square minus 2x minus 1 equal to 0, x square plus 2x minus 1 equal to 0. So x will be minus b plus or minus square root of b square minus 4ac by 2a. Here x will be minus b plus or minus square root of b square minus 4ac by 2a. So x will be 2 plus or minus square root of 8 is 2 root 2 over 2. And here x is minus 2 plus or minus 2 square root 2 over 2. So x is 1 plus or minus root 2. X is minus 1 plus or minus root 2. And x equal to plus or minus 1. This is how we can find the solution. Coming to question number 6. We have to solve this equation. Tan inverse x plus cos inverse y by root of 1 plus y square equal to sine inverse 3 by root 10. So suppose if this you will take it as theta, you will know that cos theta is y by root of 1 plus y square. That means in the triangle, adjacent is y, hypotenuse is square root of 1 plus y square. So the opposite, what you will take? The opposite according to Pythagoras rule will be 1 plus y square minus y square. That is 1. So you can write cosine inverse as tan inverse 1 by y. And here you will have tan inverse x equal to, for sine inverse also, 3 over root 10. If you take this as theta, sine theta will be 3 by root 10. If you draw a triangle for theta, opposite is 3, hypotenuse is root 10. So adjacent will be 10 minus 9, that is 1. You can write it as tan inverse 3 by 1. You can use tan inverse x plus tan inverse y formula. Tan inverse x plus y by 1 minus xy equal to tan inverse 3. You can remove tan inverse on both the sides. So you will have x plus 1 by y by 1 minus x by y equal to 3. The other side. Or you can write xy plus 1 is equal to 3 times y minus x. From the options, you have to select. The options are given as x is 1, y is 2. B is x is 2, y is 1. C is x is 3, y is 2. D is X is minus 2, Y is minus 1. So which option will be satisfied? That you have to see. Option A, when you put, you will get the correct answer. 1 into 2, 2 plus 1. And here 3 into 2 minus 1. Both the sides you're getting 3 as the answer. So option A will be the correct option. Coming to question number 7. You have to find the value of tan of cos inverse 1 by 5 root 2 minus sine inverse 4 by root 70. So if you take this as A and this as B, cos A will be 1 by 5 root 2 and sine B will be 4 by root 70. Draw a triangle for A adjacent over hypotenuse. So by Pythagoras theorem, the third side will be 7. Then take a triangle for B. Opposite is 4, hypotenuse is root 70. So adjacent is 1. That means I can write tan theta is 7, tan A is 7, and tan B is 4. So I can write the question as tan of tan inverse 7 plus tan inverse 4, which becomes tan inverse tan is outside, then you can use tan inverse x plus tan inverse y. Keeping tan outside, tan inverse x plus y by 1 minus xy. So that will be 11 by minus 27. I think this is minus in the previous page. This is minus. So you will have minus here and plus here as per the formula. And so the final answer will be 3 by 29. Next, we will go to question number 8. You have to find the value of tan of 1 by 2 sine inverse 2x by 1 plus x square plus 1 by 2 cos inverse 1 minus x square by 1 plus x square. So here we have, as per the formula, this is 1 by 2 sine inverse 2x by 1 plus x square. How can you write it as? Suppose if you take this as theta, or if you put x as tan theta, either of the ways you can do. What I mean is, if you put x as tan theta, this will be sine inverse of sine 2 theta. Same thing here, cos inverse of cos 2 theta. That means it will be tan of half into 2 theta plus half into 2 theta. That is tan 2 theta. Which will be nothing but 2 tan theta by 1 minus tan square theta. Because we have taken x as tan theta, the final answer will be 2x by 1 minus x square. Coming to question number 9. It is given that if sine inverse x plus sine inverse y plus sine inverse z equal to 3 pi by 2, then you have to find the value of x power 9 plus y power 9 plus z power 9 minus 1 by x power 9, y power 9, z power 9. So, from the given information, you can take sine inverse x as pi by 2, sine inverse y as pi by 2, sine inverse z as pi by 2, total 3 pi by 2. Total you have 3 pi by 2. Okay. So that means x will be 1, y will be 1, z will be 1. So you will have the value for this as 1 plus 1 plus 1 minus 1 by 1. That is 3 minus 1, 2. Easy way. This is the shortcut technique. Okay, we can go to the next question. Question number 10. If you are given tan inverse of 2x plus tan inverse of 3x is pi by 2, you have to find the value of x. So to solve this, I will use tan inverse x plus tan inverse y. Tan inverse x plus y by 1 minus xy equal to pi by 2. Or tan pi by 2 is 5x by 1 minus 6x square. That means this is undefined. This is infinity. So 1 minus 6x square bottom should be 0. Or x should be plus or minus 1 by square root of 6. We can take only positive. We can't take negative to get pi by 2. Only positive will satisfy the given equation. Let's go to next question. Question number 11. How many solutions? Number of solutions of this equation. Square root of tan inverse x into x plus 1 plus sine inverse square root of x square plus x plus 1 equal to pi by 2. This is what you have to use or find out. So to get pi by 2, how can we get pi by 2? This should be 0 and this should be 1. That means x into x plus 1 should be 0. That means x should be 0 or negative 1. Here, x square plus x plus 1. Getting 1, it's not possible. So what we will do? X we will take it as negative 1. That means in order to get 1, what am I doing? I'm guessing. Total I must get 1. This is the shortcut method. What I'm doing is shortcut method. Total I must get 1. So I can't put x equal to 1. Of course, I can put x equal to 0. I will get 1. So x equal to 0 is already taken. I can put x equal to minus 1 also. If I put x equal to minus 1, Then also x equal to 1 will not be satisfied. But x equal to minus 1 will be satisfied. So these two values. On the whole, x equal to 0, x equal to minus 1. Two solutions we can have. The number of solutions they're asking. So two solutions. So these are our shortcut methods you must know. For question number 12, you have to find the value of cos inverse 4 by 5 plus tan inverse 3 by 5. Now, for this, if you take the triangle theta, 4 is the adjacent side and 5 is the hypotenuse, so you have 3. That means you can write this as tan inverse 3 by 4 and then tan inverse 3 by 5. So now you can use the formula. You can use tan inverse x plus tan inverse y. Tan inverse x plus y by 1 minus xy. Or it will be tan inverse 15 plus 12, 27, 20 minus 9, that is 11. So this will be the answer. Coming to question number 13. You have to find the value of cot of sigma n equal to 1 to 23 cot inverse of 1 plus sigma to k, where k is from 1 to n. The value of this entire expression. This is not an easy one. But how can you make it easy? First of all, from here, I will pull out 2. So I have sigma k. K is from 1 to n. So I can write this as sum of first n natural numbers, n into n plus 1 by 2. So now it becomes 1 plus n into n plus 1. And then I have cot inverse. Then I have sigma n equal to 1 to 23. And then cot of this entire thing. This is how it reduces. Now I can change a little bit. Like I can keep cot as it is, whereas inside the sigma cot inverse, if I change it to tan inverse, I will write 1 by 1 plus n into n plus 1. This is how I will write. But this I can break it. Cot sigma n equal to 1 to 23. I have to break tan inverse 1 by 1 plus n into n plus 1. This I have to break. How can I break this? I can write it as tan inverse n plus 1 minus 1 by 1 plus n into n plus 1. N plus 1 minus n. This is how I can write. Or this will be n equal to 1 to 23 tan inverse n plus 1 minus tan inverse n. Because it's looking like tan inverse x minus tan inverse y formula. So if you start putting n from 1 onwards, you will be left with just tan inverse 24 minus tan inverse 1, which is tan inverse 24 minus 1 by 1 plus 24. That is cot of tan inverse 23 by 25, or cot of cot inverse 25 by 23. So the final answer will be 25 by 23. These all are the reverse of the formulas which you have already used it. So you must be good at the formulas, then only you will understand all these problems. Otherwise, it will look something new for you. Okay, we can go to question number 14. I will write question number 14 on the board. Question number 14 is finding the value of cos inverse 1 by 2 plus 2 into sine inverse 1 by 2. This formula also you have used. So you can write cos inverse 1 by 2 plus sine inverse 1 by 2 plus sine inverse 1 by 2. Cos inverse x plus sine inverse x is pi by 2. And sine inverse 1 by 2, we all know it is pi by 6. So you will have 6, 3 pi plus 1 pi, 4 pi. Or the final answer is 2 pi by 3. Because I could know the formula, that's why I could do it easily. The next is question number 15. So question number 15, you have to find value of tan of cos inverse 4 by 5 plus tan inverse 2 by 3. For this, you can draw a triangle naming angle A adjacent by hypotenuse, so the third side will be 3. For this, you can draw angle B triangle opposite by adjacent. So square root of 4 plus 9, that is square root of 30. That means you will have, as per the formula, we have taken this as A and this as B. So tan of A plus B, tan A plus tan B by 1 minus tan A, tan B. Tan A is 3/4. Tan B is 2/3 by 1 minus 6 over 12. Or you can write 9 plus 8 by 12 minus 6. That is 17 over 6 will be the final answer. Let's go to question number 16. In question number 16, you have to find the value of sine of cot inverse x. So if you take this as theta, cot theta is x. That means in the triangle, adjacent by opposite. And this will be 1 by square root of 1 minus 1 plus x square by Pythagoras. So sine theta can be written as 1 by x. The question is nothing but sine theta. And that is 1 by x. Sorry, sine theta is not 1 by x. Sine theta is opposite by hypotenuse. 1 by 1 by square root of 1 plus x square. Because that is there in the option, and actually it is opposite by hypotenuse. That's why I have changed it. Okay, next comes Oh, which question we have done? 16. Question number 17. Value of sine of 1 by 2 cot inverse minus 3 by 4. This is what you have to find. So for this, we will take this as A. So cot A is minus 3 by 4. That means in the triangle, you have 3 here and 4 here. That means this will be 5. So you can write sine of half tan inverse 4 by 3. If you take this as B, the same triangle, 4 by 3, and this is 5. So that means you can write sine of B by 2, the question. And sine of B by 2, you will write it as 1 by, okay, before writing, I will tell you the formula. On one side, I will tell you the formula. Sine squared theta by 2 or 1 minus 2 sine squared theta by 2 is cos theta. So 1 minus cos theta by 2 will be sine square, but if you take square root. So you can write square root of 1 minus cos B by 2. From the triangle, cos B is 3 by 5 by 2. So square root of 2 by 5 by 2. That is 1 by square root of 5. It can be plus or minus because we don't know which quadrant it is. Coming to question number 18. You have to find cos inverse of cos of 7 pi by 6. So for this also, we have formula. Because this is not in the range. So I have to break this 7 pi by 6 as 2 pi minus 5 pi by 6. So this will be nothing but cos 5 pi by 6, which is in the range. So the answer will be 5 pi by 6 as per the formula. Coming to question number 19. You have to find tan inverse of tan 3 pi by 4, which is not in the range. Tan 3 pi by 4 is not in the range. So you have to break it. You will write tan inverse tan of pi minus pi by 4. That means tan inverse tan of minus pi by 4. That means tan inverse of minus 1. That means minus pi by 4 will be the answer. Next, we can go to question number 20. Question number 20, you have to solve sine inverse of cos of sine inverse of root 3 by 2. So we know sine inverse of root 3 by 2 First, we have to simplify this. Sine inverse of root 3 by 2. How will you simplify this? You will write this as pi by 3. So that means you have cos pi by 3. Cos pi by 3 is 1 by 2. So now you will have sine inverse 1 by 2. That is pi by 3. Pi by 6, sorry. So the answer will be pi by 6. Next, we can go to question number 21. Quickly, we can complete one more question before we end the session. Question number 21. You have to find 2 tan inverse 1 by 5 minus pi by 4 value. So this is 2 tan inverse x formula. That is tan inverse 2x by 1 minus x square. And this is tan inverse 1 we know. So we have tan inverse 2 by 5 into 25 by 24. 5 5s and 2 12s minus tan inverse 1. This is how the question changes. Tan inverse 5 by 12 minus tan inverse 1. You can use tan inverse x minus tan inverse y. That is tan inverse x minus y by 1 plus xy. So tan inverse minus 7 by 17. But outside in the question there is tan. So if you keep outside tan, so the answer, final answer will be minus 7 by 17. So I think with this we can end the class. In the next class, we will learn about differential equations. So come prepared for that.